Hey everyone. This week's review is going to be covering what we covered in class, obviously, and that was patterns and sequences on day 1. And on day 2, we covered arithmetic and geometric sequences. What we have to look forward to next week is finding sequence formulas. So we could find not only the next term, but we could find maybe the 100th term in a pattern. So we'll learn a little bit more about that next week. So our central question for day 1 was, what are sequences? Well, a sequence is a pattern involving an ordered arrangement of numbers, letters, or figures. So an ordered arrangement of numbers, letters, figures, or other objects. A term of a sequence is an individual number, figure, or letter in the sequence. So if a sequence continues on forever, so that's forever, it is called an infinite sequence. If a sequence ends or terminates, it is called a finite sequence. Okay. The given example here, we're trying to see what has happening from here to here, and then from here to here, and then from here to here. Because of this is review, you guys know that this looks like it's plus 2, plus 2, plus 2, right? So this would be an arithmetic, right? Because of arithmetic has to deal with addition and subtraction. So this is an arithmetic sequence, plus 2, right? So it's plus 2. So we could just assume the next two things would be plus 2. So 7 plus 2 equals 9, which is stated right here. And then 9 plus 2 equals 11, which is stated right here. So this would be 9, and this would be 11. The homework assignment that I gave you guys in class was 5 problems where you would take objects or even sometimes numbers and tell me what the next things were. Now, originally you guys didn't know what arithmetic or geometric was, which is what we covered the next day, which was arithmetic and geometric. So you guys were able to tell me just based off a pattern and kind of use your guys' thoughts and be able to determine what the next term would be in a sequence just based off of you knowing patterns. Well, now in this lesson, we were given vocabulary to be able to describe what was happening in those sequences. So we have arithmetic and geometric sequences. So an arithmetic sequence is a sequence of numbers in which the difference between any two consecutive terms, is a positive or negative constant. In other words, arithmetic sequences contain addition or subtraction. So this was the key I told you guys in class. I said, this is the key right here. This is what you want to remember. Arithmetic equals addition or subtraction. Okay? And then when you're doing all this, you're going to use the constant. So the constant is the common difference and is represented by the variable d. I said, when you use the variable d, it's letting me know that you're pretty much saying it's arithmetic. Okay, so if we had an arithmetic sequence, for example, this one, -4, -2, 0, 2, 4, 6. It's going plus 2, right? Plus 2, plus 2. So you would say d equals 2, right? And this is pretty much telling me, hey, this is an arithmetic sequence of plus 2. That means you don't even have to say arithmetic. As long as you use the variable d, you are good to go. Okay, a geometric sequence has a ratio between two consecutive terms that is constant. In other words, geometric sequences contain multiplication and or division. Again, this is the key here. Geometric means multiplication or division. The constant in this case is r, right? So this is how we would state what is happening. So when you say r for the variable, you are saying, hey, I know this sequence is geometric. Okay, so looking at this example, we got 2, 6, 18, 54, 162. Well, 2 times 3 equals 6, 6 times 3 equals 18, 18 times 3 equals 54. So we can see that this is, in fact, geometric. So the way we express that is saying r equals 3. R equals 3. So one thing that I did tell you guys in class was there's multiple ways to express addition and subtraction and multiplication and division. One way to express division is to state it as So I said in class, this was my example. What is the difference? Is this true? Is this statement true? I said, is this statement true? Is the same as saying 7 times 1/2. And the fact is it is true, because 7 divided by 2 looks like this. And then when you're multiplying whole numbers or fractions, you turn the whole number into a fraction, and then you multiply straight across, which would then be 7 times 1 equals 7, 1 times 2 equals 2. So it is true, right? So you can express division as multiplication of a fraction or a decimal point. And with addition, you can express addition. So I could say, we're looking at, let's go to that example right here. I could express plus 2 or minus 2. So I would say 4 minus 2, or 4 plus 2. If I wanted to say, actually, let me correct this. It would be the same as saying 4 minus 2 is equal to the same thing as 4 plus negative 2. Those two things are equal, right? Because 4 minus 2 is 2. 4 plus a negative 2 is also 2. So there's multiple ways. I mean, there's those two ways of, you can express subtraction as an addition problem of a negative, and you can express a division problem as a multiplication problem of a fraction. So that's helpful because of when you're expressing your R's, when you're doing your expression, so you say geometric sequence, R equals 0.5, well, you would express it that way. With your D over here, you would say, well, if it was a minus 2, you would say negative 2. D equals negative 2. Okay? So that was what we covered in class this week. Next week, again, we're going to be looking at how to find the formulas for each sequence. So we not only can find the next number or object in the sequence, but we could also determine the 100th item in the sequence. So you got that to look forward to next week. Do not forget to add your summaries and your questions. I believe those are due today, actually. So I'll see you guys next week. Enjoy your weekends. Be safe. See you next time.